So let's take you have written a C program like this. Just you have a simple variable int a and printf, and you are taking one number from user and then you are printing it. Okay. Now this program you written and this you will compile. Okay. So the program you written is like the name of the program is sample.c. So sample.c is like once you say it will be stored in the hard disk, and after that you are compiling. Once you compile you will get a.out. So a.out also stored in the hard disk. Okay. Now both are present in the hard disk. After that the a.out will look like this. You have code segment, data segment. In the code segment you will have a binary of this, and the data segment you will have something else. Okay. Now you are executing the program by giving the execution command. Now the moment when you give /a.out enter, so from the hard disk this a.out will be loaded into the RAM. So who is loading? Your operating system will load. Now it is loaded. So when it is loaded, here what are the memory segment it will create? Code segment, data segment, heap segment, and stack segment. So these all are belongs to your a.out. That is your program. Now whatever you have in the code segment, that will be loaded into this code segment. Now from here the microprocessor will take one by one and it will execute. So always C program execution starts from main. So when it is coming to the main, and here in the main, which instruction it will execute first? Int a is the instruction it will execute first. So int a instruction is given. So int a means what it will do?
4 bytes of memory allocated.
It will allocate 4 bytes of memory. Where it will allocate? It will allocate. It will allocate in the stack segment. So assume that this is 4 byte and the name of that variable is a. Okay. So here you have allocated 4 bytes of memory, and after that you are asking the user to enter a number. I mean the next instruction is given that is related to printf. So it is asking the user to enter a number. So you will get a message on the screen, and after that you have a scanner. So here it is waiting for the user to give some input. Now user is giving some input. Let's take like a user is giving 25. I mean this is a screen, this is a user screen. So enter a number, like that he will get it on the screen. So now user is giving number like 25. Now that 25 whatever user has given, that will be taken and it will be stored in this memory. How it will be stored? This is what format? This is a decimal number system. This decimal number will be converted as a binary. So binary for 25, 1, 16 plus 8, 24. So like this way, rest all will be 0, 0. Got it? So it will be stored in A like this. This is the binary of 25. And after that, again you are trying to print the number which is present in A. Now in the printf, we are giving A. So in A for A you have 4 bytes of memory. In that 4 bytes of memory, whatever you have, that you are trying to print. Now, what format you want to print? So you are giving %d. D stands for
int.
D stands for decimal. So you are asking to print on the decimal format. So for this binary, see he doesn't know what is there inside. In A, for A he is having a 4 bytes of memory. In that 4 bytes of memory, whatever is there in the binary form, that he will translate it as a decimal and he will print it. So the decimal is 25. Sir, suppose if I give %O, is this okay? If I give %O, is that okay or any error?
Because numbers are in decimal only, so it will come error.
No, it is okay. It will print. But what format it will print?
Octal form.
D stands for decimal.
Decimal.
O stands for octal.
Octal.
That's all. So now, but what you have here, you have some binary. That binary will be converted as a octal. Okay. So the binary is 16. So this is the binary you have. Correct. Rest all is 0. So I am ignoring it. Rest all is 0. So this binary, you want to convert it as a octal. What you have to do is take from the right side. Take first 3 digits. Again, next 3 digits. Now you calculate 1, 2, 4, 1, 2, 4. So add. So here only 1 is present. So just 1. Here 1, 2. So 1 plus 2, 3. So 3. So this is nothing but 31 is the octal. Suppose if I give print a percentage OA, it will print 031. Hope everybody able to understand, right? Okay. Suppose if I am giving printf percentage x a,
X.
then
X.
it will print a hexadecimal. So hexadecimal in the sense, okay, let's take, see, binary is same. This will be converted as a hexadecimal, that is 1 0 0 1 1. This is your binary. This binary, when you translate it as hexadecimal, now what you have to do? From right side you take as a 4 digits. Again, next 4 digits, but here anyhow you just assume that it is zeros. So 1 2 4 8, 1 2 4 8. So here 1 plus 8,
9.
this is 9, and it will be 1. So if you print 0x 19. Okay. Is that clear for everybody? Okay. Now the same thing. Suppose user here is giving percentage O. Okay. So when he is giving percentage O while scanf. Now user is giving 25. This 25, now what number system? Octal number system. Previously we considered as like a decimal because we mentioned the D. Since now it is mentioned as a O, it is a octal. So octal 25. Octal 25. What is the binary of octal 25? So this you convert it as a 3-digit binary. 5 1 0 1 2 0 1 0. So this is the binary for octal 25. So this will be stored in this 4 bytes of memory. I mean this remaining will be remaining will be zeros. If we have given as a scanf as a percentage O. Same thing, like if you are giving it as a percentage X, also whatever the number is given, that will be considered as a hexadecimal. Hope everybody clear with the scanf and the printf. Yeah.